Alright, sorry that the last video ended so abruptly. I did not mean for that to happen, so we'll finish it here. Part C. How many adult Americans would need to be surveyed to estimate the mean age that people would like to live to within 2 years with 95% confidence? So like I was saying, you need the formula sheet to answer this last one. So I pulled up the formula sheet. I emailed this out a long time ago, and you can find it up on Moodle and the website and everything. What we are looking for is we're looking for the perfect sample size, which means we're looking for the last 3 formulas on this sheet right under confidence intervals. And the one that we are going to use is this one. So we're going to use this one because we want to use the one that has to deal with means and standard deviations, and that's this last one. These first 2 have to deal with proportions. Alright, so I already did this and wrote it all up and then had to re-record, so this is it written up already. Here's the formula. I just copied it over from the formula sheet. The perfect sample size is going to be z sub alpha over 2. The book talks a lot about how to find these z scores, but when we have a 95% confidence level, z sub alpha over 2 is going to be 1.96. The s represents the sample standard deviation. That we just get from the question, so I'm just copying that from the word problem. That's 15.5. This bottom part is the error. So if I go back to the question here, how many adult Americans will be surveyed to estimate the mean age that people would like to live to within 2 years? Within 2 years represents the error that we are willing to allow. So we're going to plug in 2 for that error. So we get the 1.96 times the 15.5 divided by 2, get that, and then square it. Whatever answer you get in the calculator, regardless of the decimal, you always want to round that up to the next whole number, which is why we rounded up to 231. Okay. Let's look at the next question. So that was mean confidence intervals. We can also do proportion confidence intervals. So question 15 on the next page, we'll do that one. In a random sample of 678 adult males 20 to 34 years of age, it was determined that 58 of them have hypertension, which is called high blood pressure. So again, I've already recorded this, which is why I sound so perturbed right now. Here's the answers to this one, and I'll talk through it. So part A, it's asking us to obtain a point estimate for the proportion of adult males 20 to 34 years of age who have hypertension. The point estimate is going to be the center or the best guess based off of the sample. Our sample has 678 as the sample size and 58 of that sample with the characteristic that we're looking for, hypertension. So to find our point estimate, also called p hat, we're just going to take 58 out of the total 678 as a decimal. That's 0.0855. So that's the answer for part A. Part B, they want us to construct a 95% confidence level. Construct a 95% confidence interval for the proportion of adult males 20 to 34 years of age who have hypertension. So let me pull up the calculator here. Should have had this up already. Sorry, I did in the first recording. And we're just going to use the calculator to calculate this 95% confidence interval. So we're going to go to the same menu that we were at before. So that was under Stat and then Tests. Just letting it pull up here. So Stat, and then we're going to arrow over to Tests. So now we are doing proportions with a confidence interval. So you're going to have to scroll down a little bit. And the option that we want here is called 1 prop z int. So proportion, z-scores, and confidence interval. If it's a mean, remember for mean confidence intervals you do t-interval. For proportion confidence intervals, 1 prop z int. It's going to have the menu, and I've already done this question, so I went ahead and plugged everything in. X represents the number of people that have the certain characteristic. 58 of our sample has hypertension. N represents the sample size. There were 678 total people. C level is the confidence level. That was a 95% again. So we're just going to hit calculate. And the calculator does all the work for us. So we get this interval, and I've already copied this over here. So our answer for part B, the confidence interval, 0.06449 to 0.1066. It also asks us to interpret that confidence interval, and I've already written a little sentence here. We are 95% confident that the population proportion of males between 20 and 34 who have hypertension is between 6.449% and 10.66%. Just changing those to percentages. All right, part C. You wish to conduct your own study to determine the proportion of adult males 20 to 34 years old who have hypertension. What sample size would be needed for the estimate to be within 3 percentage points? Again, this is where we have the formula sheet, and we're going to be using the first two. The first formula is when you do have a prior point estimate. The second formula is when you do not have a prior point estimate. We do have a prior point estimate for this question, so we're going to be using this first formula. So we're going to be plugging in the point estimate, which we found from part A, 0.0855, times 1 minus 0.0855 times z sub alpha over 2. Again, it's a 95% confidence level, so that z-score is 1.96, divided by the error. This time the question said it wanted the error to be within 3 percentage points. Just make sure you change percentage points to actually be a percent, so 0.03 instead of just 3. So we do all that and then we square it. Multiply this all out, and then we get 334 after we round this up to the next whole number. Part D is asking the same thing. It's just that part D, it says if you do not have a prior point estimate. Remember, if you do not have a prior point estimate, you want to use the second formula here. So instead of the 0.0855 stuff out in front, you would just do 0.25 out in front. Not going to bother doing that one because it's just plugging stuff into the calculator.